Hello everyone and welcome to MV Tutors. I'm Solo and I'll be looking at last year's November exam, Maths Paper 1. I hope you're doing good. I hope you're ready for this year, ready to put in the hard work in order to get those distinctions at the end of the year. So without wasting any time, please do not forget to like our videos and subscribe to our channel. And let's get started with the memo for this paper. Okay, question 1, that is where you should be getting all your marks. Try as much as you can to get the total there, 24. And what is the percentage there? So 24 divided by 150, we are looking at 16%. Okay, if you can master question 1, you already have 16%. So let us go ahead and do this. So in solving for x, we see we have a quadratic formula. You can use, we have a quadratic equation. You can use the quadratic formula or you can just factorize there. Look at the factors of 12, that will give you 1. So 2 and 6, not so, but if you have 3 and 4, definitely. And because we have a positive, we know that our 4 has to be positive. Okay, and our 3 would be a negative. So when we finally solve, we have x is equal to 3 or x is equal to minus 4. All right, at this point in time, you have probably mastered such questions. Okay, now we have 3x squared minus 2x is equal to 6. And if they say they answer questions or answers correct to two decimal places, you know that you're going to use your quadratic formula. Okay, because now factorizing it like I did previously will not work in this case. So let's bring 6 to the other side. And let's also get our calculators ready. So the quadratic equation, it's not given in the formula sheet. Please make sure you know it. So we have minus b plus minus b squared minus 4ac, and all of that is under the square root. And that is divided by 2a. So our b, we have minus 2. Please do not forget about that minus. So we have minus 2 squared minus 4. Our a is 3 and our c is minus 6. Remember that square root? And we're dividing it by 2 times 3. So this is where we take out our calculators and put in the sum exactly as it is, especially for those using Casio. I don't know, does anyone still use sharp calculators? I don't like them much. But yeah, just comment below, what calculator are you using? And are you allowed to use the calculators that can solve? We were not allowed, but I've seen some schools, they do allow it. So yeah. Okay, so if we use the positive portion of the equation, we get that x is equal to 1,79 because we're rounding off to 2 decimal places, or that x, if we put a negative, x is equal to negative 1,12. Okay. So those are the answers. Now we're going to 1.1.3. By the way, this is the section where you can, or where you should please also work on your speed. Just make sure that you are calculating accurately but fast as well. So what do we do with the sum? Let us square both sides. Okay, and the square on the left hand side is going to take away the square root, so we're left with 2x plus 1. And on the other side, x plus, oh, why did I write a plus? Let me just reduce the size. Okay, so it's supposed to be minus. Silly errors. So we have x minus 1, and if we square that, you're going to have x squared minus 2x plus 1. Okay, let's take everything to the right hand side. I don't want to work with a negative x squared. So we have x squared minus 2x minus 2x plus 1 minus 1. So now if we simplify that, we have x squared minus 4x plus 0. Okay, and then if we solve it, we're going to take x as the common factor, and we are left with x minus 4. Okay, so this has become easy for us. And then now as we solve for x, let me write that out properly. We have x is equal to 0 or x is equal to 4. But whenever you have a square root, you should always check your answer. Is it really 0 and is it really 4? So what we're going to do then, we're going to look at the original sum and substitute 0 in it. So let's see if we put 0, okay, is it going to be equal to 0 minus 1? Okay, so this is the left hand side and this is the right hand side. Okay, so on the left hand side, I have root 2 times 0 plus 1. So 2 times 0, that will be 0, and I'm left with root 1, which is simply 1. And then on the right hand side, 0 minus 1 is negative 1. So we see that x cannot be equal to 0. Now let's try 4. So we have 2 times 4 plus 1, and we have 4 minus 1. So 2 times 4, that is 8. 8 plus 1, that's 9. The square root of 9 is 3. Plus minus 3. But let's just stick to the positive side. And then on the right hand side, 4 minus 1 is 3. So I would say yes, x is equal to 4, but x is not equal to 0. So just make sure you check your answer, especially when you have square roots. Okay. Now 1.1.4. We have an inequality. So x squared minus 3 is bigger than 2x. Let's take 2x to the left hand side. So if we have x squared minus 2x minus 3 is bigger than 0. So this is a positive parabola. Okay, it's a smiley face. All right, so if you have your smiley face over there, and let's just work out what the roots are. Okay, so if you were to solve this quadratic equation, and let's just see what the factors are going to be if we're solving. Okay, so now we have x, so the factors of 3 are 3 and 1. Negative 3 plus 1 will give us negative 2. So our core roots, we get x is equal to 3 or x is equal to negative 1. So we can put there, can plot there. Actually, that circle should be open because we only have a bigger than, not bigger and equal to. Okay, so we use an open circle. So here we have negative 1, and there we have 3. So now, if we have our inequality like this, where the sum is bigger than 0, okay, remember this is our y-axis. Okay, this is not to scale, but yeah. We have our y-axis probably somewhere there, and this is our x-axis. So this is like saying y is bigger than 0. If y is bigger than 0, we're looking at every value here on top. Okay, now our answer then lies here. Okay, and basically when we write it out in full, we know that x is smaller than negative 1 or x is bigger than 3. Okay, you can see it, smaller than negative 1, and this side the answer is bigger than 3. If we had a different scenario where it was smaller than, then we're going to look here, okay, which is basically going to be inside. But we're not dealing with that. Our sum is different. Alright, now let us go and solve for x and y simultaneously. You will always have this question. I see it in every paper. I don't know if they'll ever change it. And this is where you should be scoring all the marks. Okay, so we have x plus 2 is equal to 2y. Ooh, and we have fractions. Oh my goodness. I do not like fractions. I just want to get rid of them from the get-go. Okay, so yeah, while we're at it, let's just write everything in terms of x. So then we have 2y minus 2. Okay, x is 2y minus 2. And with our second equation, let us work rather with, no fractions. So, so what we do here, if you have a fraction like this, I know sometimes students struggle with fractions. So we multiply the denominator, all right, the denominators, and then afterwards we cross multiply. So x times 1 would be x, plus y times 1, that would be y. All right, so I'm just going to remove, I'll just leave it there. And then that's equal to 1. So now I can say x plus y is equal to xy. Now I'm more confident. I can work with what I have from here on. Okay, so I've written x in terms of y. I can say that is my first equation and this would be my second equation. So how about I substitute x into the second equation, or substitute equation 1 into equation 2. All right, so x is 2y minus 2, okay, plus y, which is equal to 2y minus 2 times y. And then let us just simplify everything. So we have 2y plus y, that's just 3y minus 2. And then we have 2y squared minus 2y. Okay, let's bring everything to the left. No, to the right. So we have 2y squared minus 2y minus 3y plus 2. And then that will be 2y squared minus 5y plus 2. At this point, you can use the quadratic formula. I don't want to bust my head trying to figure out all the factors. You can do it, but we have the quadratic formula. Let's just use it. Okay. So y, we have minus b, so that's minus 5 plus b squared minus 4ac. Okay, under the square root divided by 2a. And let's see what the values of y are. So we have minus 5. Yeah, you can solve it. I mean, you can already write down some answers, but it's always safe to put the answers as they are, or the values as they are, so that you do not miss anything. I mean, I'm tempted now to say 5 squared is like 25. So I just want to write 25 as it is, but let me just stick to what I wrote here. And we have 2 times 2. So I find that y is equal to 2, or if we use the negative part of it, we can say y is equal to a half. You decide if you want to write it in decimal form or fraction form. So we have y, now we can go back to solve for x. And we said x, so here we're just going to say substitute y into equation 1. And we know equation 1 is 2y minus 2. So x is 2y minus 2. No? Yes. So we first start with y is equal to 2. And we have 4 minus 2, which is 2. Okay? So for y equal to 2, x is equal to 2. And again, x is equal to 2y minus 2. So for y is equal to half, we have 2 times a half, which is 1. 1 minus 2 is minus 1. Alright, so for y is equal to a half, we have x is equal to negative 1. Alright, and we are almost there. We're almost there. We're left with 1.3. The one thing I forgot to mention as I started this paper is please be aware of the time that you are spending on each question. This is a 24 mark question. If you want to work out how long you should spend per mark, remember the paper is out of 150 and you have 3 hours. 3 hours, how many minutes is that? 180. Okay, so you're going to take 180 minutes divided by 150. So you should be spending 1.2 minutes per mark. If we multiply that by 24, we should be spending roughly almost 30 minutes on question 1. Okay, and where are we now? 15 minutes. Okay. But yeah, just time yourself and just be as fast as you can. So now we have this sum given 2 to the power m plus 1 plus 2 to the power m is equal to 3 to the power n plus 2 minus 3n, okay, where m and n are integers, and we need to figure out the value of m plus n. So we need to figure out the value of m and the value of n, and once we have that, we can add it. So what I'm going to do now, with 2 to the power m plus 1, I can rewrite it as 2 to the power m multiplied by 2 to the power 1, all right? And we have 2 to the power m. And then we say 3 to the power n multiplied by 3 to the power 2 minus 3 to the power n. And I get a little bit excited because I see there's a common factor on both the left hand and the right hand side. So I'm going to take out the common factor on the left hand side, which is 2 to the power m. Then I'm left with 2 plus 1, which is 3. On the right hand side, if I take out 3 to the power n, I'm left with 3 to the power 2, which is 9. Let me just write it down. 9 minus 1. Okay, so then I have 2 to the power m multiplied by 3. Then I have 3 to the power n multiplied by 8. Okay, now when I get here, it's like, what is happening? How do I get m? How do I get n? What I want, okay, already I can see here that I have 3, okay, and 3 to the power n, which is great. But now I have 2 and 8. Can I rewrite the 8 in terms of 2 with the base 2? I believe I can. So let's see what we can do there. Okay. So I have 2 to the power m multiplied by 3. And this side I have 3 to the power n multiplied by 2 to the power 3, because that is 8. You can rewrite 8 as base 2 to the power 3. Okay. Now question, can I then say 2 to the power m is equal to 2 to the power 3 and 3 is equal to 3 to the power n? Am I allowed to do that? Is this allowed, or am I breaking some math rule? We're not breaking any rule. This is absolutely allowed, and that's what we're going to do. So I have 2 to the power m is equal to 2 to the power 3. I have the same base, so I can equate the exponents. So m is equal to 3. And over here, it's like 3 to the power 1, right? Is equal to 3 to the power n. I have the same base. Therefore, I can say n is equal to 1, which is great, because then I can solve for m plus n, which is equal to 3 plus 1, which then becomes 4. And with that, ladies and gentlemen, we are done with question 1, and it took us, 18 minutes. Okay, this comes with a lot of practice, I have to say. So please, as the year has begun, practice your time spent on questions. Practice doing them fast but accurately. Okay, and what I love about question 1 is whenever you get an answer, you can always check on the calculator. Does this work? Like if you're doing question 1.2, you can take the value for x and the value of y and ask yourself, if I have x plus 2, will it be equal to 2y? Okay, you can always check your answers for question 1. That's why I say make sure you bag all the marks for question 1, okay? Because it might get a bit challenging going forward. All right, now we can tackle question 2. Okay, and 2.1, it says we've been given the arithmetic series. Remember, with the series, we add the terms. If it was a sequence, we would just be given the terms. Okay, and now we need to, for 2.1.1, determine the value of the 91st term. Okay, so what I'm going to do, I'm going to look at these numbers, this series, and I'm going to try to figure out what the common difference is since we have an arithmetic series. So if I say 12 minus 7, I get 5. If I have 17 minus 12, I get 5. So that is the common difference. And we have our A value. So let's see, can we get our Tn formula so that we can get the 91st term? Most definitely. So we know our Tn formula is equal to A plus n minus 1 times D. So our first value is 7. And actually, we can actually put everything. T91. So the value of n is, okay, let me do this rather. So T91, the value of n is 91 minus 1. And the common difference is 5. Okay, how many marks were allocated? 3 marks. Yeah, so you can just definitely put everything there. Then we can use our calculator and we say 7 plus 91 minus 1. I know it's 90, but yeah, you can put it as it is or just already put the 90 instead of 91 minus 1. So our answer then for the 91st term is 457. Okay, so we've answered the question there. And then that's 2.1.1. Now 2.1.2, they want us to calculate the sum of the first 91 terms. Okay, so if you don't know it off by heart, please go check the formula sheet just to be safe. But you know, with much practice, you end up knowing these formulas, and that is another way of ensuring that you save your time. So we're looking for the sum of the first 91 terms. So in the place of n, we put 91. So 91 divided by 2. And then we have 2 times 7 as it being the first term. And then 91 minus 1 times 5. Alright. So you can put all of this in the calculator. Unless if you want to calculate step by step. But I would recommend just putting everything in the calculator in the interest of saving time. So we have plus 91 minus 1 multiplied by 5, and then put that other extra bracket, and then we can see our answer there is 21,112. So that is what you get when you sum up the first 91 terms. Okay, and then 2.1.3, it says calculate the value of n for which Tn is 517. Okay, so actually we need our Tn formula. Let's just get that quickly. So we have Tn is equal to A is 7, plus n minus 1 times D is 5. So we have 5n minus 5 plus 7. So our Tn formula is actually 5n plus 2. Alright, now that we have our Tn formula, it says what is the value for n for which Tn is 517. So we can have 517 there, and all we are left with really is to solve for n. So if I bring 5n and then I say 517 minus 2, which is simply 515. We can divide by 5 both sides. And then we are left with n is equal to, so if we say 515 divided by 5, we are left with 103. Okay, and that is the value for n. So that is 2.1 answered. Now let's go over to 2.2. So it says the following information is given about a quadratic number pattern. So this is where you need to remember how to do or how to deal with the quadratic patterns. Okay, so they've given us that term 1 is equal to 3. All right, so basically a, if we have the first term, we can then say a is 3, and then term 2 minus term 1, that's equal to 9. Okay, so let's say I have term 1 and then term 2 and then term 3. You know, when you're dealing with the quadratic pattern, you need at least 4 terms just to see what's going on there. Okay, it always helps. So term 1 is 3. Then they tell us that term 2 minus term 1 is 9. So we know that that is 9. And we know term 1 is 3. All right. I'll put it there. Yes. And then they tell us term 3 minus term 2 is equal to 21. So term 3 minus term 2, that's 21. Okay, that's great. So you can actually figure out the rest of this quadratic sequence. But anyway, now it says for question 2.2.1, show that term 5 is 111. And I say let us finish off this quadratic pattern as we have it there. So 2.2.1. So I have 3, right? 3 plus 9 will give us term 2, which is 12. So I can remove there and put in 12. And then I know that 12 plus 21, so term 3, 12 plus 21 would give me 33. All right, so term 3 would be 33. Can erase that and put 33. Okay, and then I can also get the common difference. So D would be equal to 21 minus 9. And what is 21 minus 9? In an exam, I calculate everything because I can be thinking about an answer and then I write something different. So then I know that the common difference is 12. So now, for me to go from term 3 to term 4, okay, term 4 would be equal to 21. No, not 21. I would then say the common difference is 12, all right? So 21 plus 12 is actually 33. All right, now to get term 4, I would say 33 plus 33, and that would give me 66. So I know term 4 is 66. By the way, how many marks is this question? Just 2 marks. And we're doing so much. It's okay. All right, and then now we're getting to term 5. Yes, term 5. What is term 5? So I know the common difference here is 12. So 33 plus 12. We're going to just take out our calculators quickly. And that is 45. And now what is 45? Okay, term 5. It's going to be 66 plus 45. So 45 plus 66, that is 111. And we have shown, slowly but surely, that term 5 is indeed 111 for 2 marks. So that's the nice thing about speeding up in question 1, so that when you get to such questions where you are going to spend a bit of time, you have some extra time to do such. Now it says, show that the general term of the quadratic pattern is as follows. All right, so what we're going to do, we know that 2a is equal to 2. No. Let's see, what's the first term? 2a is equal to 12. Okay, remember, we're going to start from the bottom. So 2a is equal to 12. And then 3a plus b will be equal to 9. And then a plus b plus c is equal to 3. All right, so let us work accordingly. So 2a is equal to 12. And a would be 6. Okay, we already have 6. You can see it in our answer. And then 3a plus b is equal to 9. So substituting a there, we have 3 times 6, which is 18. And if I take 18 to the other side, 9 minus 18 is negative 9. So things are coming together. All right. I'm happy so far. And then lastly, we have a plus b plus c, which is equal to 3. All right, we know that a is 6, b is 9, Now, 6 minus 9 is negative 3. If I take negative 3 to the other side, it will be positive 3. So C is 6, which is absolutely awesome because now we can write down our term formula, which is 6n squared minus 9n plus 6, and we have proved it. We have shown it that the general term is this. It's nice when things are coming together. Now 2.2.3, and then we are done with question 2. It says show that the pattern is increasing for all n is an element of capital N, so natural numbers. All right, so with natural numbers, we do know that they have to be bigger than 0. Okay, whole numbers would include 0, but natural numbers are bigger than 0. And here's the thing when you have a quadratic pattern. When you have a quadratic pattern, think about a parabola. Okay, we already have the equation of the parabola. Okay, so it's something, and it's a happy face. Happy face parabola. What I would suggest, because it says we should show that it's increasing for all values of n, which is an element of natural numbers. If you see this quadratic pattern over here, you know from the left hand side all the way to the turning point, these are decreasing values. But from the turning point all the way to the right hand side, you have your increasing values. So the reason why I want us to calculate the turning point is because after the turning point, at the turning point, remember we have a stationary point at a turning point, so the gradient is quite flat. There is no increase, there is no decrease, it's just stationary. So our answer lies after the turning point all the way to positive infinity. So it would be in our best interest to calculate the turning point, okay, to get the coordinates for the turning point. Okay, let's take a break. All right, so I'm going to use the turning point formula. Okay, you know that one where it says x is equal to negative b over 2a. Okay, but in this case we don't have x, we're actually dealing with n. All right, and so what is negative b, or what's b actually? B is negative 9, so we have negative 9 divided by 2a. All right, so then we have positive 9 over 12, and if we simplify that, we divide by 3 at the top and 3 at the bottom, we're left with 3 over 4. So I know the x value, or the n value rather, is 3 over 4. Now let us get the y value, okay, just so that we see where we are, and our y value will actually be tn. Okay, so tn, we have 6 times 3 over 4 squared minus 9 times 3 over 4 plus 6. So obviously I will not bother doing that in my head because we have a calculator. So that's 3 over 4 squared minus 9 times 3 over 4 and plus 6. So we have 21 over 8. I'm going to stick to fractions here, okay, which is simply 2,625. All right, so what do I do with that information? That is our turning point, okay? We have 3 over 4 and we have 21 over 8, okay? That is our turning point. So basically, if it says show that the pattern is increasing for all natural numbers, which are numbers that are bigger than 0, okay, then we can say, yeah, so from this point onwards, your n actually has to be bigger. Remember I said at the turning point, that's a stationary point. There is no increasing or decreasing, it's just flat. But going on, so basically for n bigger than 3 over 4, that's where you have numbers that are bigger than 0 that are increasing. Okay, so 3 over 4, that is 0.75. Okay, like we said, natural numbers are those where the values are actually bigger than 0. All right, and we've seen here that indeed n is bigger than 0, which is from 0.75 onwards, your pattern is always increasing. And that concludes question 2. And let's head over to question 3. Question 3. All right. 3.1. Given the geometric series, okay, so again we have a series, not a sequence. So we have 3 plus 6 plus 12 and on and on and on. It says write down the general term of the series. Okay, so what do we need in order to find the general term? The equation is of the general term a times r to the power n minus 1. So we need the values of a as well as r, and we know that a is 3, okay, because that is the first term. Now what is the common ratio r? So for me to go from 3 to 6, I need to multiply by 2, right? And for me to go from 6 to 12, again, I need to multiply by 2. So I now have my common ratio, which is 2. So there we go. That is our general term. 1 mark. Alright, that makes sense. Okay, now 3.1.2 says calculate the value of k. Alright, so we have sigma notation. Don't be scared by this sign, really, it's harmless. So we have 3 over 2 multiplied by 2 to the power p. Okay, and that is equal to 98,000. So they've given you the sum already. Okay, and if your unknown is in the exponent, you know that you're dealing with a geometric series. All right, so now as you sum up all these terms, you get the answer of 98,301. So how do we solve such a sum? Okay, so what I normally start with, I want to get the first term, the second term, and the third term, because we need at least 3 terms. All right, and they've already given us, because they did say the geometric series is 3, 6, and 12. But let's just say you didn't believe that this is the same as that. All right, so let's get the first term, second term, and the third term. So the first term, we would say 3 over 2 times 2 to the power 1. All right, and you get 3. The second term would be 3 over 2 times 2 to the power 2. So there we have 3 over 2 times 4. It's actually 3 times 2, then that's 6. Term 3. Now here I am calculating in my head. Please guys, just use the calculator. It's just I know that it's 3, 6, and 12. But yeah, so I want to do this quite quickly. So 3 over 2 times 2 to the power 3. So 2 to the power 3 is 8. 8 divided by 2 is 4. 4 times 3 is 12. So we can see we're back where we started. Term 1, 2, and 3 is 3, 6, and 12. So now we go to our sum equation for the geometric series. All right, and why do we go to the sum equation? Because they gave us the sum. They said the sum is 98,301. We have the first term, which is 3. We have the common ratio, which is 2. And the only thing that will be left to figure out is n. And why is that important? It's important because when you have your sigma notation, n is actually equal to k minus p. Okay, k minus p plus 1. And we know that p actually starts at, at 1. So it's actually n is equal to k minus 1 plus 1. So n is equal to k. So if we have n, then we have k. All right, so yes. Now let us look at the sum formula. If you don't know it, please have a look at the formula sheet so that you don't have to make stupid mistakes. So yeah, the sum, they've given it to us. It is 98,301. So let's write it there. 98,301. Don't mind me, guys. I'm recording with a friend over here. So if you hear a whole lot of breathing, I'm not alone. Okay, so what is A? We know that A is 3. We know that R is 2. And we are solving for N. So in the denominator, we have 2 minus 1. Okay, let's now simplify. So I have 3 times 2 to the power n minus 1. Okay, and at the bottom we have 1, so we're not gonna focus on that. And then if I multiply out the brackets, I have 3 times 2 to the power n minus 3. If I take 3 to the other side, so basically 98,301 plus 3, not minus, because I'm taking 3 to the other side. So plus 3, I have 98,304, and I am going to divide that by 3. Okay, because I want 2 to the power n all by itself. Alright, so if I do that, okay, divide by 3 both sides, and then on the right hand side I'm left with 2 to the power n, and let's see what is 98,304 divided by 3. That is 32,768. So 32,768. All right. Now my unknown is an exponent. So at this point, I mean, you can go and try to make 32 have a base of 2. 32,768 have a base of 2. But I'm not going to try to figure out that. So let's just use logs just to be safe. Okay. So now if I place a log in front, so I have log, I'm just going to swap the 2. Okay, 2 to the power n is equal to log 32,768. Or at this point, you can actually see that this is actually n is equal to log base 2 32,768. Really, it's up to you. Okay, so if I simplify this side, I have n, because I can bring down the n, log 2, and I have log 32,768. If I have n as the subject of the formula, I basically have log 32,768 divided by log 2. Okay, so you can use your calculator, you will get the same answer. Let's try with the first simple one. Okay, as I look for log, so we have log 2, 32,768, and that is 15. So we have n is equal to 15. And if I decided to do it the long way, by saying log 32,768 divided by log 2, again, that gives me the same answer, which is 15. And because we're looking for k, remember we're calculating the value of k, and we already determined that n is equal to k, or k is equal to n. We can therefore conclude that k is equal to 15. Oh yeah. Okay, and then 3.2. All right, so I'm seeing a whole lot of words, so let's just take our time in reading this. So it says a geometric sequence and an arithmetic sequence have the same first term. Okay. All right, and then it says the common ratio of the geometric sequence is a third, and the common difference of the arithmetic sequence is 3. The sum of 22 terms of the arithmetic sequence is 734, more than the sum to infinity of the geometric sequence. Okay, so a lot has been said. How can we then just try to simplify it for ourselves? Okay, so you have, we're dealing with sums here. Okay. Let's say we have the sum for, okay, let's say geometric. Put geometric here and put arithmetic here. Okay, and we're dealing here with the common ratio for the geometric sequence. So we know that R is equal to a third. And they told us that the first term is equal for both the geometric and the arithmetic. Okay, so I can then say maybe a is equal to x. Now the common difference for the arithmetic sequence is 3. So I know that d is equal to 3 and a is equal to x. Okay, now the third point, the sum of the 22 terms of the arithmetic sequence. Okay, so S22 of the arithmetic sequence is equal to 734 more than the sum to infinity of the geometric sequence. Now they want to know the value of the first term. Okay, so this is actually what I'll be working with. Okay, this is my equation. Okay, so the sum, if I simplify it again, if I say the sum of 22 terms minus the sum to infinity, I actually get the 734. Okay, now what do we do then? All right, so yeah, let's get the sum of the 22 terms. Okay, this is the arithmetic sequence, so we're going to use the equation then. Remember the equation? For Sn, for arithmetic, is actually n divided by 2, not 22. And then we have 2a plus n minus 1 d. Okay, and the sum to infinity, if you know it off by heart, that's basically a over 1 minus r. And all of that is equal to 734. And we're going to take a little break. Okay, so we know that n is equal to 22. So we have 22 divided by 2, which is 11, but it's okay. And then 2a, we know that a is x. And then plus 22 minus 1, which is 21. And the common difference they told us is 3. And then a, again, it's x. And we have 1 minus r, and we know r is a third. And that's equal to 734. So let's try to simplify on this side. So we have 11, and we have 2x. Now we have 21 times 3. Okay, 21 times 3, that should be what, 63. Okay, so then we have plus 63. And then on the other end, we have x divided by 1 minus a third. You're going to be left with 2/3. Okay, I don't like fractions, so I'm going to multiply by 2/3 throughout. Ooh. So 11 times 2/3. And that's 22 over 3. Okay, so I have 22 over 3 multiplied by 2x plus 63. And I have minus x. And now what is 734 multiplied by 2/3? Okay, 734 multiplied by 2/3. The little one wants to sleep. So I have 1468 divided by 3. Okay, so now I need to multiply by 3 throughout, because again, I still have fractions. So that's 22 times 2x plus 63 minus 3x is equal to 1468. Now I can finally take out the brackets. So I have 44x, and then what is 22 times 63? Yes, it's 1386. That's correct, my baby. And then now I'm just gonna say minus 3x and minus 1468. Or no, let me just leave it on the other side. Let's just leave it here. So now we're going to take 1386 to the other side, and then 44 minus 3, that will be 41x. And then what is 1468 minus the answer? We have 82. And then if we divide by 41 throughout, we get that x is actually, I don't know if you see this, but x is actually equal to 2. If we say 82 divided by 41. Okay, so now that we know that x is equal to 2, the first term, a, is 2. And we are done with question 3. Alright, see you later. Alrighty, now let's get to question 4. Sketched below is a graph of f of x. Alright, so it is an exponential function that has been shifted 4 units down. Alright, and they've given us the domain that we're focusing on, which is from -2 up until 4. And then a and b are respectively the y and the x-intercepts of f. Yes. So now, 4.1, we have quite a few questions to answer over here. It says, write down the equation of the asymptote of f. Alright, so we know that we have a horizontal asymptote. And in this case, it's simply y is equal to -4. Alright, and then 4.2, it says determine the coordinates of b. Now we can see that b is the x-intercept. What happens at the x-intercept? Well, basically that is where y is equal to 0. Okay, so x-intercept, y is equal to 0. Yes, so we have 0 is equal to 2 to the power x minus 4. So if we take 4 to the other side, we have 2 to the power 4 is equal to 2 to the power x. Okay, so now we have 2 to the power 2 is equal to 2 to the power x, the same base, meaning the exponents are equal. So now we have that x is equal to 2. Okay, and therefore we can write the coordinate of b and say that b is actually 2 and 0. Okay, and then 4.3, determine the equation of k. What is k? It is a straight line passing through a and b in the form. So basically, I don't know if I can make any marks on this. I don't think so. Ooh, okay. This is going to be complicated. But anyway, so if we have our exponent over here, and we have a and b, basically the straight line will be something like that. Okay, and if we need a straight line, the equation rather, we're going to need a gradient as well as a point. So we already have point b. We should actually get a, which is the y-intercept, so that we can get the gradient. So yeah, let's go right ahead. So yeah, let's first get the coordinates of a, which is the y-intercept. And with regard to the y-intercept, we know that x is equal to 0. Okay, so now we say y is equal to 2 to the power 0 minus 4. Anything to the power 0 is 1, right? Okay, this is not gonna work. So then y is equal to minus 3. Yeah, I'm not the only one who wants to talk. Yes. Alright, so now we can get the coordinate of a, which is basically 0 and minus 3. Okay? So there we have it. And then now we can get the gradient. Agreed? Yeah. Oh, you know what? No. When you have 2 points, you can actually use that to get the equation of the line. And let me show you. So we have y minus the y coordinate of b and x minus the x coordinate of b, which will be equal to the y coordinate of b minus the y coordinate of a. That's basically the gradient. X coordinate of b minus the x coordinate of a. And what is the y coordinate of b? It's basically 0. Okay, so we have y minus 0 And the x-coordinate of b is 2. We calculated that. Okay, so just repeat again. And the y-coordinate of a is -3, so this becomes a +3. X-coordinate of a, that is simply 0. So now we have a y, and we have x minus 2, and then we have 3 over 2. Okay, so now our formula in the form of k x, that's simply going to be 3 over 2x. And what is 3 over 2 multiplied by 2? Well, it's 3, but let's just do it. 3 over 2 multiplied by 2, you are left with 3. So therefore we have -3, and that is our equation over there. Okay, we have found it for 4.3. Now we can move on to 4.4. Okay, so it says calculate the vertical distance between K and F at x is equal to 1. Okay, so where x is equal to 1, you basically want the y value for K and you want the y value for F. So let's go then and get the y value for K at x is equal to 1. So that's basically going to be 3 over 2 times 1 minus 3. Remember, 3 over 2 is like 1.5. So 1.5 minus 3 is -1.5. So we can just say the answer is -3 over 2. And then now f with 1. Alright, so we have 2 to the power 1 minus 4. Anything to the power 1 is itself, so 2 minus 4 is -2. Okay, now they want the vertical distance. So basically, I'm just going to say VD, the vertical distance between K and F at x is equal to 1 will basically be the negative 3 over 2 minus -2, and that is a half. Okay, -1.5 plus 2 is a half. And there we got it, or a half units, right? Because this is distance. We don't know what units are given, so just write units. Now, 4.5, it says, write down the equation of g if it is given that g of x is equal to f of x plus 4. Okay, this should be a bit straightforward, but let's just write it out. So g of x is f of x. What is f of x? That's basically 2 to the power x minus 4, and then we add 4. So we see the 4's cancel, so g of x is practically 2 to the power x. And then 4.6, so it says write down the domain of the inverse of g. Okay, so basically, if this is g, then the inverse of g will be reflected about the line y is equal to x, and it will look something like that. Okay, with this. Okay, so now if we're going to write down the domain of g, the domain of g is actually the range, or rather, okay, let me write it down. So the domain of the inverse of g is actually equal to the range of g. All right, and what do we know as the range of g? We know that the range of g, if we have a look at g, and that's the inverse of g, so the range is pretty much from 0 to infinity. Okay, so the domain as well will be from 0 all the way to infinity, with none of them included, right? Because 0 is where the asymptote is, and infinity, we don't know what it is, so we use round brackets. Okay, but because they're looking for the domain, we say x is an element of. Okay, and there we go for 4.6. And now heading over to 4.7, it says write down the equation of this inverse. Okay, so we know that g of x is 2 to the power x. Okay, same as saying y is 2 to the power x. Now if we want the equation of the inverse, we simply swap x and y around, and then we apply our logs. So we know that y is equal to log base 2x, okay, because they wanted it in the form y is equal to, and then we have log base 2x. And that is it with question 4. There you go with your 14 marks. Question 5. So we have the graphs of f of x and g of x, where f of x is the parabola that has a sad face, and g of x is a hyperbola. And then they say the point of intersection of f and g is b, the turning point of f. The graph f has x-intercepts at -3 and 0, as well as 5 and 0, and a y-intercept at c. Okay, this looks like an interesting functions question. So let's look. 5.1. Write down the coordinates of the turning point of f. I mean, the equation of f has been written such that we can easily see what the turning point is, right? And you'll know if it's written in this form. This would be your x coordinate and that would be your y coordinate. Okay, so basically the turning point of f of x will be 1 and 8. Okay, not -1. You can see that b over here is on the positive side of the x-axis. Okay, now 5.2, it says calculate the coordinates of c, and we know that the coordinates of c, that's basically the y-intercept of f. Alright, so let's go ahead and calculate the y-intercept, where we know that x is equal to 0. So we take our equation, I'm just going to use y instead of f of x. And where we have x, I'm just going to put a 0. And basically, I have -1/2 times -1 squared, which is just 1, plus 8. So -1/2 plus 8 is actually 7.5. Okay, or we could say 15/2. Up to you. 15/2, or you can say 7.5. Alright, so far so good. Now 5.3, calculate the value of d. Now the value of d, that's when we're looking at our hyperbola. That's d over x. My question is, as you look at d, alright, are you expecting a positive or a negative answer? Okay, remember, if you have a hyperbola that uses the quadrants 1 as well as 3, if you were to put a straight line through those quadrants, then you can see that the gradient is positive. Okay, and that tells you that the value of d in this case would be positive. But if you had your hyperbola occupying the second and the fourth quadrant, and if you were to draw a straight line through it, then you would see that the gradient is actually negative. So not -1, but negative. So we would expect then d to be negative. Okay, so that's the first thing. Whatever it is that you get for this scenario where the hyperbola occupies the first and the third quadrant, we are expecting d to be positive. Now, what do we know at this point? Do we have anything? Yes, we do. So we can substitute. What value can we substitute actually? So if I say y is equal to d over x, I can use the value of b, all right? Because I can see that b is a coordinate on the graph of f, but it's also a coordinate on the graph of g. So as long as you have any point along the graph, then you can use it, okay? And I can see b is the only one that I have. I don't have any other point. So I'm going to substitute the coordinate of b. So in the place of y then, I would put 8. And in the place of x, I would put 1. Okay, we're taking it from 5.1. In the place of x, it's 1. In the place of y, it's 8. And then you can see then that d is equal to 8. Okay, so if you were to write down the graph of g of x, you would simply say 8 over x, and that 8 is positive. Okay, now 5.4. It says write down the range of g. Okay, g, our hyperbola, You see that we just have a normal hyperbola. There hasn't been any vertical shift. There hasn't been any horizontal shift. Okay, so in that case, the equations of your asymptotes are actually going to be y is equal to 0 as well as x is equal to 0. Now in this case, they are asking for the range. Okay, so the range here, it can be any number, honestly, right? So y is an element of real numbers, but we cannot use y is equal to 0 because there we have our asymptote. So you say y is an element of r, but also y cannot be equal to 0. Because if you leave it at y is an element of r, then you are assuming that all the values are applicable, including 0. Okay, but with a hyperbola, there's always an asymptote somewhere. Okay, so just be careful. And then 5.5, it says, for which values of x will f of x times g of x be smaller or equal to 0? So basically, if I have f of x and I multiply it by g of x, so if the y values for f multiplied by the y values of g, where are they smaller and equal to 0? That's basically where I need either my f of x has to be negative and my g of x has to be positive, because if I multiply the two, I'll get a negative, or f of x has to be positive and g of x has to be negative, then I'll get a negative. Okay, so let us go and see then. All right, so in this case, we have g as negative, and we also have f as negative until it gets above. Okay, the y values now become positive. Okay, above the x-axis, the y values are positive. Even here, they are positive, 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 and then negative, negative, negative. So I'm looking for opposites here. So when g is negative, f has to be positive, or if f is positive, g has to be negative. Okay, I hope I said that correctly. So anyway, I see here f is positive, all right, from negative 3 onwards, and g is negative. So this at this point is applicable. Then we have both of them being positive, which is not what we want, but then eventually f becomes negative and g becomes positive. So those are the two scenarios that would be applicable. All right, so when we write our answer, we're then going to say from negative 3 up until from negative 3 up until 0, where we have our asymptote. Okay, and we're going to use a square bracket because we have smaller and equal to. So from negative 3 all the way to 0, and 0 cannot be included because that is where the asymptote is. Okay, so basically those are the values of x. So x is an element of negative 3 all the way to 0, and we now go from 5 all the way to infinity. Okay, because we know that our hyperbola will never touch the x-axis. So we start from 5. We start from 5, and we can include it because there's no asymptote there, and it ends up to all the way to infinity. All right, I hope that was clear. I know these questions can be a bit tricky, but whenever you see f of x, g of x, think the y values of f, the y values of g. What happens if I multiply those y values? And then just put for yourself on the graph, where is it positive, where is it negative, and it will make answering this question or these types of questions much easier. All right, so that's 5.5. Now 5.6. So it says, for 5 marks, calculate the values of k so that h of x is equal to negative 2x plus k will not intersect the graph of g. Remember g, that is your hyperbola. Okay, so let's just say, so this is your graph. Let me just put there h is equal to negative 2x before shifting it up or down. Okay, now they're saying it mustn't intersect the graph of g. So k can move all the way up, okay, until it barely touches g, or you can move it down. So k can be, positive moving up or negative moving down, okay? But it's not allowed to touch g. So we need to know what is that upward value that k can be. And because it says here, calculate the values. So it's more than one value for k. So there's a group of values here that are positive and there's a group of values here that are negative. So how are we going to tackle that? What I'm going to do, I will see then, what if we took h of x and we make it equal to g of x? And why am I doing that? I'm doing that so that I can see what k values I'm dealing with here. But I know that ultimately the k values will have to be in between a certain value and a certain value. Okay, remember, it will be in between some value here and a value here. All right, so we know that k has to be in between some values, but what are those values? Now let's take the graph of h of x, and they told us it is negative 2x plus k. All right, and then g of x, that's basically 8 over x. And now we're going to solve, and when we have a k there, you should immediately think about the discriminant, but let's just multiply out and then we'll get there. So if I multiply through with x, I get negative 2x squared plus kx is equal to 8. And if I take 8 to the other side, to the left hand side, I get negative 2x squared plus k times x minus 8, and that is equal to 0. And remember, our discriminant is basically equal to b squared minus 4ac. Okay, so now what are we going to do with the discriminant? Actually, when we say the discriminant is equal to b squared minus 4ac, we're talking about real roots, when it has real roots. But in this scenario, actually, we're going to have 0 being bigger than b squared minus 4ac. And if we substitute the values there, according to our equation, we know that b is actually k. So you have k squared minus 4, a is negative 2, and c is negative 8. So let's just work that out, and so that we can see what k values we can use there. So I have negative 4 times negative 2 times negative 8. And that gives me a value of negative 64. That's actually great that we have a negative because we have a difference of 2 squares. So now we can factorize and say k minus 8. Remember 64, if you root it, square root it, it will be 8. Positive and negative 8. Okay, so we have k minus 8 and k plus 8 because of the difference of 2 squares there. And now, in that case, we can say 0 is bigger than k minus 8, or 0 is bigger than k plus 8. All right, so when we solve for k, we can say that if we take 8 to the other side, we say k is smaller than 8. And on the other side, we say k is smaller than negative 8. No, not quite. All right, and this is where looking at the graph actually helps. All right, so I can agree that once you've reached this point over here, it would have shifted 8 units up. And once you've reached this point over here, it would have been 8 units down. So in actual fact, k has to be in between negative 8, we start with a smaller number, and 8. Okay, and we can't include equal signs because they said it should not intersect the graph of g. So k is bigger than negative 8, but it is smaller than 8. So that's how you would write your final answer. All right, and now we get to the last question, 5.7. So it says h is a tangent to g at r. Okay, remember h of x, let's just put it down here just in case you have forgotten. It is negative 2x plus k. All right, so h is a tangent to g at R. And what else? A point in the first quadrant. Okay, calculate t such that y is equal to f of x plus t intersects g at R. Whew, that was a load. What do they want? What are they looking for? Okay, so now if I were to just remove all of this and just sketch just to see what is actually happening over there, so that we can just answer this question. Okay, so h of x is negative 2x, right? Plus k, and we've realized that k can be between negative 8 and positive 8. But also it is a tangent to g at R, which is in the first quadrant. So let's just say our graph of h of x is there. It is a tangent to g at R. Okay, and whenever you hear tangent, I hope what's coming at you is getting the first derivative, because the first derivative will be equal to the gradient. Okay, and the gradient here of h of x is actually minus 2 there in front of x. Okay, so that's the first point. H is a tangent to g at R. So we know if this is our R, that the gradient there is minus 2. Okay, a point in the first quadrant, because if it was in the third quadrant, then we'll be dealing with a scenario there. But we're dealing now with the first quadrant. Now it says calculate t such that now we have a function y is equal to f of x plus t intersects g at R. So basically we are taking f of x and we are shifting it down. Okay, let's use a different color. Shifting it down such that it intersects g at R. So b, all of it is going to go all the way down. So we're going to probably have something like this, which is y. Okay, and we need to calculate t, this vertical shift. So when we go from b all the way to there, that is t, that is our vertical shift. So we are expecting t in actual fact to be negative because it's shifting down, and we don't know how many units that is. Okay, I hope that is a bit clear if I show it graphically there. All right, so we know h of x is negative 2x plus k, and we've just said as well that the gradient for h of x is negative 2, and we're going to use it, right? And g of x, remember, it is 8 over x. Okay, so what I want to do, what my plan of action is, I want to get the first derivative of g, all right? And that first derivative is the gradient. And we know the gradient at that point is negative 2. And by so doing, I'm looking for the x-coordinate of R. Once I get the x-coordinate of R, I can also get the y-coordinate of R. Then I know what my point R is. All right. And once I know what my point R is, I can substitute it in the f of x formula. Okay. And after doing that, or in my y formula where it's equal to f of x plus t. And after doing that, I can get the value of t. Okay, so let's see what we can do here. I'm going to rewrite g of x, because I don't like fractions, as 8 times x to the power negative 1. If you bring x to the top, it will have a negative power. All right, and then I'm going to differentiate. Okay, get the first derivative. And if I do that, I'm going to get negative 8 and then x negative 2. Okay, so basically it's like saying negative 8 x over x squared. Okay, if I simplify it. And remember, this is actually the gradient. So then I can say the gradient is negative 2. And then I can solve for x. Okay, so I'm going to take x to the other side. I have negative 2 x squared is equal to negative 8. And if I divide by negative 2 throughout, I get that x squared is equal to 4. Okay, and if I solve for x, it's actually going to be plus minus 2 if I square both sides. But we are dealing with the first quadrant. That's where r is, remember? So the x value has to be positive. So therefore, x is in actual fact 2. That is the x coordinate of r. Now, what is the y coordinate of r? Remember, r is on the graph of g. So if I put there 2, and I say 8 divided by 2, I get 4. Okay? So now r, the coordinates for r is 2 and 4. Okay, so that's great. I know what r is. I know the point is 2 and 4. Now I go to my equation. Y is equal to f of x plus t. And what is f of x? F of x, remember, it is negative a half. And I have x minus 1 squared plus 8. Then we have the t. Then we have the y. So I'm going to then, because we said our parabola is going to move t units downward until it touches the graph of g at r, I'm going to use r's coordinate, 2 and 4, in the place of y and x. Sorry about that. So yes, we're going to substitute the point r into our equation. So in the place of y, we're going to put 4. And in the place of x, we're going to put 2. And our only unknown in this instant would be t. So it has worked out quite perfectly. Alright, so we have 4 this side. And we have 2 minus 1, which is 1. 1 squared is just 1. So we have negative a half plus 8 plus t. And that's basically 7.5. So if I take 7.5 to the other side, I'll basically have 4 minus 7.5, which will be negative 3.5. Yeah, 3.5 plus 4 would be 7.5. So negative 3.5, and that would be equal to t. Okay, or we could say t is negative 7 over 2. However way you want to put it, it works. So I hope that was clear. If it isn't, please just comment down below. If you have another way of doing it, please just enlighten the other students as well. We're here to help one another succeed. Okay, so yeah, that is it for question 5. Question 6, we are past the halfway mark, and I just wanted to know from you, how are you finding this paper? Is it easier than the previous years? Was it fair? Was it a bit challenging so far? I think it was very fair. I think it is fair so far. So let's just see going forward what will happen. Okay, so 6.1. Patrick deposited an amount of 18,500 into an account earning R% interest per annum compounded monthly. After 6 months, his balance was 19,319 Rand and 48 cents. Now, for 6.1.1, calculate the value of R. Alright, so let's write down the things that we know. So we know that the principal amount, the amount deposited, was 18,500. The interest rate is R% over 12 because it's compounded monthly. Our period is 6 months. And the accumulated amount is 19,319 Rand and 48 cents. Okay, so we're going to use our compound formula because we're dealing with a compound amount. It's not like an annuity where you are putting in the exact amount for, for periods like monthly, quarterly, yearly, or whatever. This is just a once off. So this equation is applicable. And since now we are looking for the interest rate, I'm going to try to write I as the subject of the formula before I start putting in the values. So let me just bubble this. So then I have A over P and it will be root n, okay, 1 plus I n root n, and then the root n and the power n are going to cancel, so I'll be left with 1 minus I, so I will be equal to root n a over p minus 1. Okay, and remember, the I is equal to R percent divided by 12. So basically I will be saying 12 multiplied by, there's a lot going on here, but I hope you can follow. Okay, now I can start putting in the values. So R percent will be equal to 12 times, okay, so N is 6, A is 19,319,48, and that is divided by 18,500. This is very risky what I'm doing. Putting everything there at the end. Should anything go wrong, we are in trouble. But the nice thing is that you can always test your answer. Once you solve for R, you can put it back into the equation and then see, are you going to get the same value for A? Okay, we'll actually do it. We're not pressed for time, so we can do it. So shift, I have 6, numerator 19,319,48, denominator 18,500, and then we are subtracting 1. So I have a value there of 0,087. Okay. And if you want to put it in percent form, we can actually say R is equal to, multiply that by 100, 8,7%. And let's just test quickly if this works out. So if I put 8.7% and I'm looking for A, this is us testing. You do this when you have time, all right? If you don't have time, please do not do that. So 1 plus 8.7% all over 12 to the power 6. Okay, so 8.7%, let me just divide that by 100 again. Okay, so I have that, it's 0,087. So I can say 18,500, 1 plus the answer, oh gosh, divided by 12. I don't know what this calculator does this. And then to the power 6. You see, we get 19,319,48. So you are then certain that actually this is the correct amount. Okay, because we did get that 19,319 rand and 48 cents. Now, 6.1.2, it says calculate the effective interest rate. So the nominal is 8.7. Now we need to get the effective. Okay, please, whenever you take out a loan or you're investing, just make sure that you know whether you're dealing with nominal or you're dealing with effective. All right, so calculate the effective interest rate. So the formula for that is 1 plus the interest rate that's effective is equal to 1 plus I to the power m all over m to the power m. Okay, so if I put everything in terms of the effective interest, it's the same, and minus 1. All right, so let's put in the missing values. So we have 1 plus the effective interest rate is 8.7. No, not the effective, the nominal is 8.7% divided by 12 to the power 12 minus 1. And now let's see. All right, so we have 1 plus 8.7%, or let me just say 8.7 divided by 100, and then divide by 12. and then to the power 12. Oh, minus 1. Whew. Yo. All right. So now we get the effective interest rate to be 0,091. Or if we multiply by 100, we get 9,06%. Okay. I need to change the settings in this calculator. My goodness. What is it doing? All right, so that's 6.1. Now let's head over to 6.2. Kuda bought a laptop for 10,000 Rand on 31st January 2019. He will replace it with a new one in 5 years' time on the 31st of January 2024. Okay. So, the value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. After how many years will the laptop have a value of 0 Rand? So basically, where it doesn't have any value at all. So let's just summarize the information that we know. We know the principal amount it was bought for, 10,000, and the period at hand. If it's from 2019 to 2024, that's 5 years. What else do we know? We know that the rate of depreciation, okay, it's going to say D, that's 20% per annum. And okay, A. All right, so according to this question, we're actually solving for N, so we don't know what N is yet. Okay, so let us just keep that as a question mark. And when are we getting to 0 Rand? So basically what we're going to do now, because they said it's a straight line method, remember if it's a straight line, our equation should be along the lines of y is equal to mx plus c, but we're not going to really use mx plus c. It's basically a is equal to p1 minus, okay, in this case this is plus in, but because this is depreciating, we're going in that direction, we're going to use this equation, 1 minus I times n. All right, so let's get to calculating. So we have A is equal to P and 1 minus I times n. We have 10,000. We have 0. We have 1 minus 20%, which is 0,2. And n is what we're trying to solve. Okay, so if we take 10,000 to the other side, well, that's basically 0. And if we take 1 to the other side, we have negative 1. And we have negative 0,2n. So basically n would just be taking the negative 1 divided by 0,2, or negative 0,2 rather. And then we get 5. Okay, 5 years. So basically it takes the 5 years to depreciate to a value of 0 rands. I don't think anything can really depreciate to 0 rands. But anyway, it is what it is. That's what we're calculating over here. So now 6.2.2, it says Kuda will buy a laptop that costs 20,000 Rand. Now, in order to cover the cost price, he first made his first monthly deposit into a savings account on 28 February 2019. He will make his 60th monthly deposit on the 31st of January 2024. The savings account pays an interest rate of 8.7% per annum compounded monthly. Calculate Kuda's monthly deposit into his account, or this account. Okay, so now here, you can see clearly we don't have a lump sum that we're dealing with, but we actually have an annuity where you're paying a certain amount on a monthly basis. All right, so he wants to buy a laptop that costs 20,000. Now another thing, if it's an annuity, is it a future value annuity or is it a present value annuity? Because he's saving for an amount to get or saving for an amount in the future, and he's starting to pay back now into the account, not pay back, but to pay into the account in order to accumulate 20,000 Rand. This is a future value annuity. Okay, it's a future thing. He's planning to get 20,000 after so many years. So we're going to use the future value formula. All right, and now what do we need? Let's just put in the information. So we don't know what that monthly deposit is going to be. We know the interest rate. I'm starting from the bottom going up. It's 8.7% compounded monthly. And 60th, okay, monthly deposit. So we know that N is equal to 60 months. And basically, the future value that we want is 20,000. Okay, so I think we have everything in order. Now, I forgot the formula, so I definitely need to check out the formula sheet in order to see for future value. I normally confuse it with the present value. So, future value, we have our monthly amount, 1 plus interest, power n minus 1, and all of that we divide by the interest rate. Okay. So the future value amount is 20,000. And we're looking for X. Actually, let me do my dangerous thing. So we have the future value multiplied by the interest. And then we're going to divide by 1 plus the interest to the power n minus 1. And that will be equal to X. So X is equal to the 20,000. And the interest rate is 8.7% divided by 12. And then we're dividing all of this by 1 plus 8.7% divided by 12. Let me just go back to the question. This 8.7% looks like the previous question we did. Yes, we are dealing with 8.7%. Okay. And that's to the power 60. And we are subtracting 1. Alrighty, so we have 20,000 multiplied by, I'm just going to say 8.7 divided by 100 all over 12. We have 1 plus 8.7 divided by 100 divided by 12. And that is to the power 60. And we are subtracting 1. So then we see that the monthly amount is going to be 267 rands and 26 cents. Okay. That was a nice 4 marks. And then 6.3. Tino wins a jackpot of 1,600,000. He invests all of his winnings in a fund that earns interest of 11.2% per annum compounded monthly. He withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20,000 Rand will Tino be able to make from this fund? Alright, so Tino has received money today. It is 1,600,000. So because of that, we're going to use the present value annuity. Okay, that's how you can determine the difference between a present value and a future value. If you're getting money in the future, it's future value. If you're getting money today, whether it's through an inheritance, whether it's through winning the lottery, whether it's through taking a loan from the bank, then it's present value. All right, so let's just summarize. The present value that we have, that is 1,600,000. All right, the interest that has been spoken of, it's 11.2% per annum compounded monthly. The X value will be 20,000. And now we're looking for how many withdrawals, right? So that's N. Let's just bubble all this information and go and get the present value formula. It's equal to X. So we have 1 minus 1 plus the interest rate to the power negative N. And that's all divided by the interest rate. Okay, so we're looking for N. Ooh. If I say present value multiplied by the interest divided by X minus 1, that'll be equal to negative 1 plus I to the power negative N. I'm just going to leave it there. So the present value is 1,600,000 multiplied by the interest, which is 11.2%, divided by 12. All right, and that is all divided by the monthly amount, which is 20,000, and we're subtracting 1. And then in here we have 1 plus 11.2% divided by 12, negative N. Okay, let's just calculate. So we have 1,600,000. Let's see, 1,123,123. Okay, and multiplied by 11.2%. All right, that's divided by 12, all over 20,000, and minus 1. So that gives us negative 0.253 recurring. Okay, and on this side we have negative. Let me just save this, store this, shift store A. Okay, cool. And then we have 1 plus 11.2% divided by 12. And that is just, I'm just going to say 757 or over 750. I mean, even this previous amount, I could have left it as a fraction, okay, so that I don't have to refer back to it. It's negative 19 over 75. Okay, so we have an unknown as an exponent, so we can use our log function. Okay, so we have what? 19 over 75 is equal to 757 over 750 to the power negative n. So then we can say negative n is equal to log of the base 757. 757 over 750, and then multiplied by 19 over 75. Okay, so negative n is equal to, let's see, log of 757 all over 750, and then 19 over 75. So that's basically equal to negative 147.8. And now we see 147.8. We can round it off to 148 withdrawals. Always round up. Okay. And that's it for question 6. Question 7, we're going to deal with calculus. All right, so determine the first derivative from first principles, and it's 5 marks. Guys, this is where you should score your marks. Literally, you cannot get this wrong. Okay, what answer are we expecting? If we just use the power rule, 2 times negative 4, negative 8x, that's what we're expecting. If you don't get negative 8x, then you're somewhere is wrong. Okay, Now, they wanted it from first principles, so let's do it that way. All right, so the limit as h tends to 0, please make sure that you always put this. Okay, so this is the formula that I happen to remember. You can check it out on the formula sheet if you have forgotten. All right, always include the limit or else your answer will be wrong. So what is f of x? It is negative 4x squared. So now when we say x plus h, wherever you see x, just replace it with x plus h. Okay, so for example, we have negative 4x plus h squared. And it will be minus 4x squared divided by h. Alright, so if we multiply it out, we'll have x squared plus 2xh plus h squared. And we have plus 4x squared, and we are dividing that by h. Okay, we keep carrying that limit. Okay, so let's multiply in the negative 4. We have negative 4x squared, negative 8xh, negative, not a positive, but negative 4h squared plus 4x squared. Again, that's divided by h. And again, the limit as h tends to 0. So we're going to cancel these ones out. And then we have negative 8xh minus 4h squared all over h. Now let's take the common factor out, which is h in the numerator. So we're left with negative 8x minus 4h divided by the h. So these h's cancel out. And again, for the last time, the limit h tends to 0. We have negative 8x minus 4h. Now, if we then substitute 0 where h is, what are we left with? We are left with negative 8x. Is that what we had initially? Yes. So we know that we are right, and that is a nice 5 marks. 7.2.1, we need to get the first derivative. Okay, so what is f of x? It is 2x cubed minus 3x. Okay, fair enough. We're going to use the power rule, not first principles. Ooh. So there we go. 3 times 2 is 6, and 3 minus 1 is 2. And then we have, remember there's a 1 there. 1 times negative 3 is negative 3. And 1 minus 1 is 0. X to the power 0, that's just 1. So we're not going to write that down. So that is a nice 2 marks. And now 7.2.2. Yeah, the derivative of all of that. Let's firstly just write it out nicely. So we have 7. And then we have x squared. That's cubed. Okay, so it's the same as saying x to the power 2 over 3. And then we have plus 2 x to the negative 5. Okay, so now when we get the first derivative, okay, let me just say y is equal to, so if we get the first derivative, yeah, so that's basically going to be 2 over 3 times 7. That is 14 over 3. Okay. And then we have x. So 2 over 3 minus 1, that should be negative 1 over 3. But let's just make sure. Yeah, negative 1 over 3. So negative a third. Alright, and then we have negative 5 times 2, which is negative 10. And then minus 5 minus 1, that's minus 6. So I think you can leave it like this. Or if you want to take it back to the third form, what you can do is say 14 over 3 But ooh, that negative. Yeah. Okay, it's going to be 14 over 3. Yeah. I would leave it here, honestly, just so that I don't complicate my life. Because now this just looks, yeah, doesn't look so lacquer. Okay, and then this side we would have negative 10 over x to the power 6. But like I said, this should be enough. All right, and then the last question, 7.3. All right, so it says, for which values of x will the tangent to f of x have a positive gradient? So we have a cubic function, all right, and it is a negative cubic function. Remember, a negative cubic function has a sad face at the end. Okay, yeah, sad face at the end. All right, let me just remove that. So this is what we have. Okay, now it says, for which values of x will the tangent have a positive gradient? Now, using a different colored pen. So this here, we have a negative gradient. And here, our gradient is 0. And then here we have a positive gradient. And there, our gradient is 0. So here, m is positive. No. M is negative. Here m is positive, and then we have a negative gradient over here. So what are they talking about? It says, for which values of x will the tangent have a positive gradient? So we are looking at this region over here. Okay, the tangents here. That's why, yeah, values of x. All right. And yeah, so how are we going to work that out? If you see tangents, you must know that we are dealing with the first derivative. And because we're saying that the gradient must be positive, then we're going to say the first derivative, which is equal to the gradient. But in this case, the gradient has to be bigger than 0. Okay? So what is then the first derivative of negative 2x cubed plus 8x? Okay, firstly, that is 3 times negative 2 is negative 6. And we have x, 3 minus 1, that's 2. So negative 6x squared. And then 8x, we're just going to be left with 8. And that has to be bigger than 0. So that's how, yeah, we're going to work it out. So now we have negative 6x squared is bigger than negative 8. If I divide by the negative, I will have 6x squared is smaller than 8. All right, still with me? And now we're going to solve for x. So we're going to say x squared smaller than 8 over 6. And we're going to just root both sides. And basically, we're going to get, in this case, x smaller plus minus root 8 over 6. Okay, or we can simplify it. Instead of 8 over 6, we can say 4 over 3. If we divide by 2. All right, but because we have a plus and a minus, x will be in between those values, because x can't be smaller than root 4 over 3 and also be smaller than negative 4 over 3. So basically x is going to be in the center. Okay, so we have negative root 4 over 3 and positive root 4 over 3. Let's just check what root 4 over 3 is, just in case we shouldn't leave it in surd form, because they didn't say anything. Or did they? It's 1,15. Did they say anything about surd form? No, so let's just say negative 1,15, positive 1,15. And that is it for question 7. Question 8. All right, so given the cubic function, they were very generous. They wrote it in for us in the form of ax cubed plus bx squared plus cx plus d, and also they have gotten the factorized for us, so that's quite nice. Now it says for 8.1, determine the coordinates of the turning points. Remember, by the way, this is a negative cubic function, right? So it looks, it ends up with the sad face. All right, so this is how it looks. So if they want the coordinates of the turning point, remember at the turning point, that is where the gradient is 0. So it's stationary, okay? Whereas here, the gradient is smaller than 0. There, the gradient is bigger than 0. Here, smaller than 0. So basically, we are getting the first derivative and making it equal to 0. Okay, our gradient is equal to 0. Now let's get the first derivative. We're going to use the first form that they gave us. So the first derivative, 3 times negative 1, that will be negative 3x squared. And then 6 times 2, that's positive 12x. And then minus 9. And that will be equal to 0. So I'm going to divide everything by negative 3. And then I'm going to get x squared minus 4x plus 3. Alright, so I can factorize easily here. I don't need to use the quadratic formula. I can just use 3 and 1 because those are the factors of 3. It's a prime number. And for me to get a negative 4, I'll have negative 1, negative 3, that gives me negative 4. And negative 1 times negative 3 is positive 3. Okay, so then I can say x is equal to 1 or x is equal to 3. Now remember, they asked for the coordinates, not the x values. So once you're done, take the value of 1 for x and let's get the y value. Okay, so we're simply going to put in 1 there. Okay, so we're basically saying minus 1. Well, let me just do it like this so that when we enter 3, it's just easy. Okay, so we have that, negative 1 cubed, and then plus 6 times 1 squared minus 9 times 1 plus 4. Oh, so that is 0. Okay, so firstly we have a coordinate of 1 and 0, and then if we substitute 3 in there, what will we get? And now we get 4. Okay, y is equal to 0 or y is equal to 4. So now we have 3 and 4. All right, so I could say then within the sketch, on this turning point we have 1 and 0, and on that turning point we have 3 and 4. That's how we're expecting our graph to look. And then speaking of graphs, it says sketch, draw a sketch of graph F, clearly label all the intercepts with the axis and any turning points. So we have the turning points, right? Now in terms of the intercepts, so let's just write it down. Our y-intercept in this case, if we substitute x is equal to 0, we're going to get it to be 4. All right? And then our x-intercepts, where y is equal to 0. Remember I said they were generous. They wrote it out for us. So now what we can then see is that once they factorize, it actually looks like this: x minus 1 squared, and then we have minus x plus 4. If you have x minus 1 squared or have a bracket that is squared, that tells you that is the turning point. Okay, so we know then at 1 and 0, at our turning point, that's also the x-intercept. Okay, so now we're left with minus x plus 4. So if we work that out, our other intercept, minus x plus 4 is equal to 0. So we know that x is also equal to 4. All right, so now we can sketch our graph. All right, We know on the y-axis we're gonna intersect 4. So this is 1, 2, 3, 4. Okay, we can extend it a bit or not. Just leave it there. So we know we're gonna pass through 4. And if we have again 1, 2, 3, 4, we know at 1 we have a turning point. So just put it there. And at 4 we have an intercept. And we have a turning point at 3 and 4. So also somewhere there we have a turning point. Okay, so now we can sketch. It makes life just a little bit easy. Alright, and then yeah, actually it should be something like this. We have a turning point there, and we have an intercept. Oof. It's tough sketching these things to scale, so I think let's do it like that. Okay, and then maybe let's shift our 1 a bit. It makes sense for 1 to be here, but you catch the drift. Okay, make it clear that's 1. Okay, put it there, 1, 0, 4, 0, and that one, let's just remove that little bit there. Obviously you're going to draw it much nicer than me, so that will be 3, 4, and that will be 0, 4. And how many marks is it? 4 marks. Yeah, I think we've shown everything that we need to, and that should be enough. Now 8.3. Use the graph to determine the values of k for which this cubic function will have 3 real and unequal roots. Okay, so currently this is the situation at hand. I'm just going to redraw it. Can I just use a different colored pen? So we have something like this. All right, at the moment we have 2 equal roots and another root. Okay, but now they want 3 real and unequal roots. So what do you think? We can actually take this. Okay, I wanted to select this entire thing. Let me do it like this. Okay, so if we can take this, if we need to have 3 unequal roots that are real, we can shift it down. Okay, so then we have 3 roots. I hope you see. 1, 2. Okay, I'm busy counting here. I'm not showing you. But at this point, we have 1, 2, 3. If we shift it down. Okay, if we shift it up, now I can't shift it anymore. But if we shift it up, we were probably going to have it flying in the air. Something like this. And then it would only have 1 root. All right. So in this case, the value of k has to be negative. Okay. For all of this to happen. Now, how many marks is this? Because they said use the graph, we don't have to go and physically calculate. We can determine what k has to be. Okay, and currently this space, let me just use a different color. Okay, so this space over here is 4 units. If we keep taking down this graph, we can only take it to a point where we don't want this scenario. We don't want this. Because now we're going to have 1 root and 2 equal roots. Okay, and we also don't want this scenario there as well, where it's only just 1 root. We want to work between the 2. Okay, so we can only shift our graph between 0 and 4 units, if that makes sense. If I shift my graph exactly 4 units, I'm here now. Okay, and I have 1 root and 2 equal roots, which is what I don't want. If I leave my graph as it is, again, I have 2 equal roots and another root. But in order for me to have 3 unequal roots that are real, I have to shift my graph. Okay, so the k value, therefore, by looking at the graph, by inspection, it has to be, you can shift the graph more than 0 units, but less than 4 units. I hope this makes sense. Okay, that's how you would shift the graph, between 0 and 4 units. If it's at 0, it doesn't work. If it's at 4, it also doesn't work. All right, and that is your 2 marks. Now 8.4. Okay, now we can keep this the same. Let's just lift this. So 8.4, the line g of x, which is a straight line, is tangent to f at the point of inflection of f. Now determine the equation of g. All right, so the point of inflection, remember this is our graph. The point of inflection is where we have concave down to concave up. And if it's tangent, then we're looking at something like this. So we're looking for the equation of this graph. All right, we're expecting a positive gradient, so A should be positive. B, well, we'll see. But yeah. So remember, the equation of f of x is negative x cubed plus 6x squared minus 9x plus 4. Whenever they speak about the point of inflection, what we're looking at is the second derivative. So let's just remind ourselves, what is the first derivative again? We have negative 3x squared plus 12x minus 9. And now the second derivative, which we use to get the point of inflection, we can then say 2 times negative 3, that's negative 6x plus 12, and we make that equal to 0. All right. And then when we solve for x, we have 6x is equal to 12. So x is equal to 2. So at that point where x is equal to 2, that's the point of inflection, okay? That's a coordinate. So let's just get the y coordinate for that. And remember, in order to get the y coordinate, we will substitute x is equal to 2 in the original equation. Okay, minus 9 times 2 plus 4. I hope I still have that equation. Yes, I do. So let's just put in 2. Oh, we get 2. All right. So our point of inflection, just going to say pi, is 2 and 2. All right. So we have a point, right, which is the point of inflection. We're looking for a formula here. So we need a gradient. And we know that it's at the point x is equal to 2. So we can use the first derivative because that is equal to the gradient. All right. And that is equal to negative 3x squared plus 12x minus 9. And we know that the x value that we're going to use there, because this is like that, so we're going to substitute 2. All right, and we can get what the gradient is. Because like I said, in order to get the equation of a line, straight line, you need a point, you also need a gradient. So yeah, we have negative 3 times 2 squared, which is just 4. And then 12 times 2, which is 24, and minus 9. And so we get the gradient to be positive 3. And looking at our sketch, is it positive? Yes, the gradient should be positive. So that's great. Now we have a point, we have a gradient. We can go to the equation y is equal to mx plus c. Let's substitute in the y value, which is 2, the gradient 3, x value 2. So what would the c value be? It would be 2 minus 6, which is negative 4. Therefore, finally, the equation of g of x, so in this case, a, which is our gradient, that's 3. So we have 3x minus 4. Okay, and that is our function or the equation of the tangent line. Are we almost there? I feel like I've been talking so much. 8.5. Now calculate the value of theta, the acute angle formed between G and the x-axis. So back to our graph. That's what it is. Remember, that is our x-axis. Let's remove that. And let us put in the x-axis. Okay, so there's the x-axis. And now we want this angle, theta. Okay, let me use a different colored pen. So this is theta. Okay, and remember, we take it from the x-axis all the way to the line. We never go this side, guys. Please don't ever do that. All right, and that is easy because we know what the formula is. Okay, so with maths, you cannot forget anything. What you know from paper 2, you must know as well from paper 1. So we have tan theta is equal to the gradient, and we know that the gradient of the line is 3. So theta will be the inverse of tan or arctan 3. And you must make sure that your calculator is on degree mode, not radians. Okay, so DEG, right? And then we have shift 10. No, what's that now? Shift 10, yes, 3. And we get 71,57. It's important that your calculator is on degrees, because if you put it at radians and you set shift 10, 3, you're going to get 1,25, and that's not, which is radians, yes, but you're going to put that answer in degrees, which is wrong. And I mean, if you look at your graph, you are expecting a value of theta that is close to 90 degrees because it's quite steep. All right, and that's it for question 8. See you at question 9. The diagram below represents a printed poster. The rectangle ABCD is the part on which the text is printed. This shaded area is 432 centimeters squared, and AD is x centimeters. ABCD is 4 centimeters from the left and right edges of the page, and 3 centimeters from the top and bottom of the page. All right, I'm just going to draw this out for myself and put in the extra information that they gave us. Okay, I just want to deal with the printed portion. Okay, because they said, yeah, they put there some interesting stuff. Now we know that the area there, this is A, B, C, and D. The area is 432 centimeters squared, and they told us that AD is x. So if AD is x, BC would also be x. Okay, they didn't say anything about AB or CD, so I'm just going to say that's y. All right, and then yeah, we have, actually let me put in the bigger portion. Okay, so let me just copy and paste that and then put information. Make that red. It didn't change. Change style, red, done. Okay, let's put it here. Make it a bit bigger. All right, so because we know that we have 4 centimeters over here and another 4 on the other side, I would say 8 centimeters plus x. I don't know if I'm going to need this, but I'm just putting it there. And then we have 3 plus 3, so that's 6. So 6 centimeters plus y, that would be the area if I wanted to get it, just the length and the breadth. Okay, those are the kind of things I would put in my exam paper so that I can answer questions that follow. So now it says, show that the total area of the page, okay, is given by that. All right, so what I'm going to do then, I can say the area of this page is actually 8 plus x, the 8 centimeters plus x, multiplied by the 6 centimeters times y. All right, I don't know what that area is. I only know the area of the smaller rectangle. So if I multiply in, I'm going to get 48, 8 times 6, and then 6x, and then 8y, and then xy. All right. Now what else do I know? So the area of the small triangle, okay, I should say area for big, and then area for small triangle, that's actually x times y. Okay, and they told us the area there is 432. And so now I can put this formula in terms of y, or in terms of x, but let's just put it in terms of y because they didn't really say anything about y. They told us information about x. So y will be equal to 432 over x. And also it's because my answer it does have x in it. So it wouldn't make sense to put it in terms of y. Let's put it in terms of x. And now I go back to my area. I'm just going to put it as ax actually. And then I have my 48 there, my 6x, 8y, so 8 times 432 over x, and plus x times y, so x times y. Let me just do that. All right, so x times 432 over x. Whew, all right, will this work out? Well, it has to work out. So I have 48 plus 6x. Do I have a 6x? Yes, I do. Okay. And then 8 times 432. 3, 4, 5, 6. That's great. So at least I have 3, 4, 5, 6 over x, and I have 6x. And then x and that x will cancel out, so I'm left with 432. All right, so let's start with 3, 4, 5, 6 over x. And let's go with the 6x. And then what is 432 plus 48? It's 480. And I am smiling from ear to ear because I have shown that the total area of the page is given by this formula. All right. And 9.2, it says determine the value of x such that the total area of the page is a minimum. As soon as you hear minimum, maximum, please just know we're going to get the first derivative. Okay, now let me write this with no fractions. So I have 3, 4, 5, 6, x to the power negative 1 plus 6x plus 480. Now the first derivative, I'm going to make that equal to 0. So if I multiply negative 1 times 3, 4, 5, 6, I'll get negative 3, 4, 5, 6, and x to the power negative 2 plus 6. All right, and I'm going to make that equal to 0. So another way of rewriting it, I'll have negative 3, 4, 5, 6 divided by x squared is equal to negative 6. If I take this x squared to the other side and multiply by negative, I have 3, 4, 5, 6 is equal to 6x squared. Let me take this 3, 4, 5, 6 and divide it by 6. And I get 5, 7, 6. So x squared is equal to 5, 7, 6. And if I square root both sides, I'll get 24, but it's actually plus minus 24. Now, they're asking for the area of the page, if the area of the page is a minimum. Okay, so we have x is equal to 24 and we have x is equal to negative 24. What do you think we'll use? The negative or the positive in order to get the minimum? I say check out what a is if you use 24 and what a is if you use negative 24. Then you'll know what is the real answer for x. Okay, we're just checking here. Let me take it a bit lower. Okay, so our area, like we said, it is 3456 over x, so let's say over 24, and then plus 6 times 24 plus 480, we get an area of 768 centimeters squared. Now with the negative 24, we get an area of 192 centimeters squared. So do you see this would be your maximum area and this is your minimum area. Therefore, x is actually equal to negative 24 centimeters. Yes, x is AD. So yes, it should be negative 24 for it to be a minimum. All right. And yeah, I think that is it. Actually, no, x is not, it's not AD. Or it is, because they said AD is x. I'm just thinking we don't really have a negative measurement. So let's just say x is equal to negative 24 and leave it at that. And yes, because you can see if you use negative 24, you get the minimum. And that's it for question 9. And we are at the last question, question 10. I don't want to lie, guys. This paper was nice. The challenging bits were not that hectic compared to previous years. But anyway, I'll hear from you what you guys think. So 10.1 says A and B are independent events. All right. So as soon as I hear independent events, I think about this formula. Probability of A and B is equal to the probability of A multiplied by the probability of B. All right, and they tell us that the probability of A is 1/3 and the probability of B is 3/4. So what is then the probability of A and B? That would be equal to 1/4. All right. Now, 10.1.1, it says determine the probability of A and B. Okay, we kind of did that. Let's just put it as 10.1.1. Yeah, what's 10.1.2? Determine the probability of at least one event occurring. So if it's at least one event occurring, that's basically saying, probability of at least one event occurring, that's basically equal to the probability of A. All right, A alone, and then you have because that's at least A happening, or at least B happening, or at least A and B happening. Okay, that's how I look at it. And okay, this is A alone. I don't want to say A because we have the probability of A. So this is like probability of A alone, probability of B alone. And what do I mean by this? I think it will make more sense if I draw the Venn diagram. So if this is A and if that is B, we know that A and B is 1/4. And then we know that A, the whole A, that is actually 1/3, okay? But if I wanted to get A only, this is A only, what will I say? I would say 1/3 minus the intersection. which is the quarter, and I would get 1 over 12. So A only is 1 over 12. And if I wanted B only, same thing. I would say 3 over 4 minus a quarter, which is simply a half. Okay, so then I go back to my formula and I say A alone is 1 over 12, B alone is a half, and then A and B is a quarter. Okay, so basically the probability of at least one event occurring it'll be 1 over 12. Okay, 1 over 12 plus a half plus a quarter, and that is 5 over 6. Some of you might be like, oh, what a long way of doing it for just 2 marks. Hell no. Yes, so there's an easier way of doing it. So basically, you could say the probability of at least one event occurring, that's basically going to be the probability of A plus the probability of B minus the probability of A and B. It's simplifying what I did basically. So probability of A is a third, probability of B is 3 over 4, and the intersection is a quarter. And if you work that out, you should get 5 over 6. So basically we have a third plus 0.75 minus 0.25, and you get 5 over 6. Okay, so you have 2 ways of doing it. Awesome. Now let's get to 10.2. All right, so it says the probability that it will snow on the Drakensberg Mountains in June is 5%. Okay, when it snows on the mountain, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 72%. If it does not snow on the mountain, the probability that the minimum temperature in central South Africa will drop below 0 is 35%. Now represent the given information on a tree diagram. Yeah, so once you start seeing dependent events, you know a tree diagram is coming up. So basically, what information have they given us? They said if there is snow, there's 5%. Okay? Meaning, if there is no snow, that's 95%, because it all has to add up to 100%. And then they said if it snows, okay, so basically where do we start? We start over here and we go with snow, probability of snow, and probability of no snow. So snow, 5%, no snow, 95%. Then they say, when it snows, the probability that the minimum temperature will drop below 0 degrees is 72%. So are we going to drop below 0 degrees, or will we be above 0 degrees? Okay, so when it drops below 0 degrees, the probability there is 72%. So if it is above 0 degrees, it's the remainder. So 100 minus 72, I think that is 28. Okay, 28 plus 2 is 30, 30 plus 70 is 100. It's fine, don't need to check. Okay, now it says if it does not snow. So this is the snow scenario, this is the no snow scenario. So if it does not snow, the probability that the minimum temperature will drop below 0 degrees, again we have below 0 degrees Celsius, that is 35%, meaning if it's above 0 degrees, that would be 65%. So that is our tree diagram. Yeah, that's it. That is 10.2.1. Now 10.2.2. It says calculate the probability that the temperature in Central South Africa will not drop below 0 degrees. Okay, so probability of it, if it doesn't go below, it means it will be above. Yeah, how did I write it here? Okay, so we're looking at above 0 degrees Celsius. The probability of having no drop below 0 degrees Celsius. So we're going to take a different shaded pen and we're going to say, okay, we're looking at the snowing part, but that it won't drop below 0 degrees, then we're going to go here. And then no snow, it won't drop below, we're looking here. So how do we put that in a calculation? Well, basically we're going to say the 5%. You can either write it as 5% or you could say 5 over 100. It's really up to you. Multiplied by 28%. Okay, and we're adding the 95% and multiply that by 65%. Or 65 over 100. It's all good. So now let's see. So we have 5 over 100 multiplied by 28 over 100 plus 95 over 100 multiplied by 65 over 100. And we get 0, let's just make it a percentage. So multiply by 100. So we're going to get 63.15%. And does that answer make sense? Yes. Because in Central South Africa, we don't really have such cold temperatures. So the probability that you're going to get temperatures higher than 0 degrees, that should be high. This is Africa. Okay, so yeah, it's only in those special places where you have snow. And then 10.3. 10 learners stand randomly in a line, one behind the other. Okay, so we have 10 students, learners. So 1, 2, 3, 4, 5, 8, 9, 10. All right, now in how many different ways can the 10 learners stand in a line? Okay, so that's simply what we would say 10 factorial, right? Because the first position we have 10. Once one is sitting down, we have 9, 8, 7, it goes all the way down. Okay, and then the last seat, there's only one person. Hence, we have 10 factorial. I don't even know if they want us to actually put the value of 10 factorial, but just put it there just in case. So that is 3,628,800. Okay, and then now 10.3.2, it says calculate the probability that there will be 5 learners between the 2 youngest learners in the line. Okay, what does this mean? So let's say we have our 10 available spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we must have 5 learners that are together. Okay, I'm just going to take this. Okay, 5, 4, 3, 2, 1. Okay, and then these 5 learners, they go ahead with 2. So there must be 1 learner at this side and 1 learner at that side. Okay, occupying them. They must be in between them. All right, and they however the way they move, they must move together. Okay, they're like one unit, if I could say. All right, and if that's the case, so these 2, they can also, sit this side or that side. So we have our 5 factorial over here, and with these 2, we sort of like have a 2 factorial. because they can also move and, swap around. And remember, we're taking this as one unit. So this is like, they are one thing. Okay, so we have 1, 2, 3, 4. Okay, so now considering all of that, that would be 4 factorial because it can move around as it wants. Okay, I hope I'm making sense with all of this. Now then, how do we then write it out? So the number of possibilities here that we have, we basically have 5 factorial multiplied by 4 factorial multiplied by 2 factorial. Okay, 5 factorial because these 5 learners can sit anyhow. Okay, 4 factorial because this one group, and 2, 3, 4 can sit anyhow. And 2 factorial because these 2 that are surrounding these 5 can move about anyhow. Okay, so what do we have there? If I have 5 factorial multiplied by 4 factorial multiplied by 2 factorial, I have 5760. Now the question was not how many possible ways can these kids sit. They said calculate the probability. Calculate the probability that 5 learners between 2 learners or 2 youngest learners in a line, blah, 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 blah. So what I'm going to take is that 5760 and I'm going to divide it by the total, okay, which is 3,628,800. Okay, or if you wanted to write it all out, you could have said 5 factorial times 4 factorial times 2 factorial all over 10 factorials, just so that there aren't or there isn't a mess. Okay, so, or any numbers that are just excluded. So we have 5 factorial times 4 factorial times 2 factorial divided by 10 factorial. And no, what did I do? This is not a factorial. Oh my goodness. Okay, 10 factorial. All right, so the probability then is 1 over 630. Or if we multiply that by 100, we would get 0.16%. Okay, and that is the probability that there will be 5 learners between the 2 youngest learners in the line. And with that, ladies and gents, we are done with this paper. Yeah, I hope this year goes very well for all the matric students. Maths is not bad, it just needs a lot of practice. So if you can start now, then I guarantee you'll get good marks. Do not leave things to the last minute. With the things that you are doing in the first term, make sure you ace them. All right? And that's it from me.